In today's video, I want to talk about how machines think, or more specifically, do they think? You see, by now, I hope that you're buying into the premise that artificial intelligence is amazing. And if we build it and then use it for the right reasons, we could achieve some truly amazing things. And I'm not talking about those special photo filters the world seems hell-bent on using. And I'm pretty sure that as Alan Turing marveled at his conception of the Turing machine, he wasn't overwhelmed with a desire to give people bunny ears and angel wings. He was definitely onto something. In fact, during one of his earliest public lectures on the topic way back in 1947, he claimed that what was needed was a machine that could learn from experience and then alter its own instruction. Turing, the grandfather of computers, often discussed that computers could solve new problems by learning from experience, that they could understand new challenges through heuristic problem solving. So let's run with that and see just how intelligent machines have become. Now, before we jump in, we need to define intelligence. What is it? Is it free thinking? Is it mastery through repetition? Or is it something more divine? Psychologists generally define it as a combination of diverse ability, which, let's be honest, could mean anything. But what we're beginning to understand is that, at least in the realms of artificial intelligence, focus is placed on the following key components. This is learning, reasoning, problem solving, perception, and language. Let's look at these in more detail and investigate 3 ways in which computers learn. We'll look at supervised, unsupervised, and reinforcement-based methods. Let's start with supervised. And as you can probably guess, it means someone looking over the shoulder of the CPU and judging whether the computer is getting things right. It means having a full set of labeled data while training the algorithm. This way of teaching means that each example you present is tagged with the answer so that the machine can learn through association and repetition. It's like teaching your child to read with those phonic cards. You know, the ones that you hold up for hours on end saying things like car, only to then later regret those actions when it becomes the only word your child will ever say. Now, you're probably thinking, but wait, we don't hold up flashcards to a computer. But the thing is, we kind of do. Think about those apps that can identify objects. You know, the one that says, that's a car, that's a bike, that's a person. Well, the computer only knows that because somebody has painstakingly gone through the images telling the computer that that's a car, that's a bike, that's a person. In fact, companies like Samasource are helping thousands of people lift themselves out of poverty in developing countries by paying them to do these annotations and break down complex data projects. By doing so, machines can look at new images and then predict the likeness that what they are seeing falls into one of the trained categories. But it's not just classification. Supervised learning also shows potential in regression-based problems, or problems based on contiguous data. I don't know, think about an estate agent, for example. They could use regression-based machine learning to calculate the value of a home. By taking the independent variables, i.e. the location, the number of bedrooms when the house was built, and then using them with dependent value, i.e. the house price, they're able to predict market value as circumstances change. But what happens when we don't have perfectly labeled data sets, or we ask questions that haven't been trained? This type of learning is called unsupervised. With this model, the machine is given the data with no explicit instructions or an example of the desired outcome and simply asked to get on with it. The neural network then tries to make sense of it all, desperately trying to find structure to the data and formulate a pattern. Now, unsupervised learning can organize data in many ways. This could be through clustering, i.e. matching colors, shapes, or species, or anomaly, whereby it detects unusual patterns. Think about how your bank checks for fraudulent activity, or how sometimes your card won't work abroad. This is down to a machine thinking that something is perhaps a little off. Maybe it's association. We've all bought things online and then been prompted with recommendations to consider as we check out. This is because machine learning models have determined that these recommendations may be of interest by simply matching key attributes. The thing is, by having no absolute truth, it's difficult to measure how effective unsupervised learning will be. But what we do know is that machines are amazing at finding patterns, and largely thanks to high power computing, they can do so at record pace. So our last example is reinforcement-based learning. And as the name suggests, this training is based on two aspects: exploration of what is not known and exploitation of what is. Think of it like playing a video game. How many times have you tried to complete a level only to run into an enemy or some other entity that cuts the game short? Through perseverance and reacting to what has been learned, you eventually complete the level. This is the very essence of reinforcement-based learning. This cut and dry approach simply works through trial and error. The algorithm evaluates a situation, it then acts. It receives feedback and adjusts accordingly to maximize long-term reward. A sufficiently developed reinforcement-based learning algorithm can be extremely useful in environments that have dynamically changing pools of tasks. Think of applications such as advertising, whereby machine learning models can rank products, or manufacturing through remote process automation. Perhaps it's the financial sector that uses these models to evaluate trading strategies, or universities teaching machines how to play chess. What we do know is that whatever model we run, artificial intelligence is gaining momentum, especially within the business community, where it's helping companies better understand customer interactions. It's improving decision making, cutting costs through automation, and improving data security. But wait, where can you learn more? I hear you cry. Well, whether you're completely new or a seasoned professional, head over to the Microsoft AI School, where you'll find a whole heap of information, in addition to learning materials and tutorials that will help you start building intelligence into your own solutions. Thank you.